What's up, guys? We're back with section 5.2 from our textbook, which has to do with solving quadratics graphically. Now, section 1 was all about graphing quadratics. And so this section really piggybacks off of that. It's more conceptual. We're not adding too many new skills, technical skills, but it's all about the understanding. So take a look and see what's on the screen right now. It says, what does it mean to solve a quadratic equation? That's a fair question. How do we solve it? Well, we need to find x values that make the equation true. So I started off with a very simple quadratic equation. It has an equal sign, has the x squared as the highest degree term. So x squared equals 4. I need to find x values that make this true. And you might be looking at that and saying, well, that's pretty simple. X equals 2. 2 squared equals 4. That is very true. There's a second answer, and some of you might have picked up on that. What else? Well, x could equal -2, right? Because -2 squared, -2 times -2 is +4. So this quadratic actually has two answers, x equals 2, x equals -2. But we don't want to hope it's a really easy equation like this. X squared equals 4. That is not a great way to go, to just cross your fingers and say, I really hope that this is something I know off the top of my head. So we have a few different ways to solve quadratic equations. And we're going to start by solving them graphically. And in future sections, we'll see different algebraic ways to solve. But here, we're going to start by solving them graphically. So how do we do this? We got to make sure that the equation is equal to 0. And once we have the equation equal to 0, we're just going to graph it, kind of like we practiced last section. And then we're going to find the roots. Now, roots, as you can see from that little parenthetical down there, the roots are where the graph hits the x-axis, wherever we hit the x-axis. The roots have all sorts of different names. Sometimes they're called roots. Sometimes they're called x-intercepts, because it's where they hit the x-axis. Sometimes they're called solutions, because what did we say? This is how we solve quadratic equations. So sometimes they're called roots, solutions, x-intercepts, and zeros. Zeros is the other common name because that's where y is 0, where we're hitting that x-axis. So you'll hear all of those. I will keep reminding you kind of that they are interchangeable. But let's see how this works with our equation that we kind of knew the answer to. We just figured it out, 2 and -2. So if we have x squared equals 4, step 1, make it equal to 0. So I'm just going to say x squared minus 4 equals 0. Step 2 is graph. Well, step 1.5 is graph. So a is 1. We have 1x squared. We don't have any x's. That means b is 0. We have 0 x's. C is -4. So step 1, step 1 while I'm graphing. Sorry, I know I keep saying step 1. I'm going to find my axis of symmetry. Axis of symmetry, x equals -b over 2a. So that's -0 over 2 times 1. And 0 over anything is just 0. Axis of symmetry, x equals 0. So I'll kind of put that on my graph. My graph got a little misaligned, it looks like, from my graph paper. There's my axis of symmetry. All right, what did we do next last section? We said, well, now that we know the axis of symmetry, let's find our vertex. We know that the vertex is somewhere on that line, so I know that my vertex is at 0, something. And let's just plug in 0 to my equation above, x squared minus 4. So 0 squared minus 4, 0 minus 4. This one turned out pretty easy. The vertex is at 0, 1, 2, 3, comma, -4. There's my vertex. I also know that this opens upwards because I have a positive x squared, right? So I'm gonna now just do one of these guys. 0 I know is -4, we figured that out. Let's plug in 1. So 1 squared minus 4 is 1 minus 4, so -3. Symmetry. So I know that I can reflect that and say -1 has to be -3 as well. And what about 2? So 2 squared minus 4 equals 4 minus 4, so that's 0. And that means negative 2 should also be 0. And if you remember kind of what those notes said at the very start, the solution here, after we've graphed it, the roots that we're looking for are where the graph hits the x-axis. And lo and behold, as I'm blowing these roots up, these points, lo and behold, those roots where we hit the x-axis are negative 2 and positive 2. Just like we kind of figured out because it was a really simple quadratic equation. So 2 and negative 2 are the roots. They're where we hit the x-axis. If we can graph, we can find the roots. It's that simple, okay? So this is what I mean when I say all the technical skills that we went over in the last section, we get to reuse them. We don't have to learn them, relearn them, and learn a new way to find the roots, because we can reuse all those this section and just see where the graph hits the x-axis. So next example, we're only doing 3 examples total. And so let's take a look at this one. Negative x squared plus 4x equals 3. I need to make this equal to 0. That's going to be step 1 in almost every strategy to solve quadratic equations. So I'm going to say negative x squared plus 4x, I'm subtracting the 3 over, equals 0. Okay, it's equal to 0. Now I need to graph it. Start with your axis of symmetry. You know how to do this. X equals negative b over 2a. B in this equation, how many x's do we have? We have positive 4. So negative b, so negative 4 over 2 times negative 1, because we have negative 1 x squareds. Negative 4 over negative 2. Axis of symmetry, x equals 2. I'm going to put that down on my graph so that I know where to kind of mirror image and reflect over. Let's find our vertex. So I'll make my table. 2 is in the middle of the table because it's in the middle of my graph. It's my vertex. So negative, and I'm plugging it in here, remember, just to that left side. So negative 2 squared plus 4 times 2 minus 3. So do the squared first. 2 squared is 4. So negative 4 plus 8 minus 3. Negative 4 plus 8 is positive 4 minus 3. It looks like 2 comma 1 is my vertex. Okay. We know how to graph this. I'll plug in 0 because I love plugging in 0. It's the easiest one ever. Negative 0 squared plus 4 times 0 minus 3. Well, that's just going to be negative 3. So 0, 1, 2, 3. 0, negative 3, which means on the other side, 2 on the other side, I can put a negative 3 down there. I'll plug in 1. I'll plug in 1 and say, so negative 1 squared plus 4 times 1 minus 3. So 1 squared is 1, got to do that first. So negative 1 plus 4 minus 3. Negative 1 plus 4 is 3 minus 3, 0. This is good news for us. We graphed it. We know our vertex. I didn't label that earlier, but that's 2 comma 1. But what are we really interested in? What is this section all about? Solving this quadratic equation. We set it equal to 0 right here. And then on the graph, we're trying to figure out where does it hit the x-axis? What are those roots? Well, we have them in our table. X equals 1 and 3 are my solutions to this quadratic equation. Now, one way to check this would be just to plug those back into the original. Because we're at the very start of the lesson, we said solving means finding x values that make this equation true. Let's plug in 1. Is negative 1 squared plus 4, is that equal to 3? So do the squared first. Negative 1 plus 4, is it equal to 3? Yes, it is. And what about if we plug in 3? Is negative 3 squared plus 4 times 3, is that equal to 3? So that would be negative 9 plus 12, is that equal to 3? Yes, it is. So you can always check just by plugging in those x values back into your original equation. Okay, there's one more problem we're going to work. Before we do that, oh, scroll down too far. Conceptually, we kind of went over this with linear equations a lot. How many solutions could a quadratic equation have? We keep seeing them have 2. Is that the only possibility? Turns out no. But we've seen them like this, where there are 2 equations. We also could have a situation where, what if that's the parabola, what I drew on the very right-hand side? Where does it hit the x-axis? Well, it doesn't. So there's 0 equations there, or 0 solutions there. And then there is the possibility that there is one single equation, one single solution if the vertex is on the x-axis, meaning it just goes down, it nicks that x-axis, it just hits it once and comes back up. And so it's possible for a quadratic equation to have 2 real solutions, 1 real solution, or 0 real solutions. You notice I just put the word real in there, and that might have caught your attention. More on that later. But for now, 2 real solutions, 1 real solution, or 0 real solutions. Can we use a calculator to solve for roots? Answer, yes. So step 1 is going to remain the same. Make it equal to 0. 2x squared minus 7x minus 4, because we're subtracting both of those over, equals 0. Then we're going to take this and plug it into our calculator. So on our calculator, and by now I'm hoping we're somewhat familiar with graphing a little bit, I'm going to hit y equals, I'm going to say 2x and hit that squared button. It's just diagonal from the 7, just up and to the left. 2x squared minus 7x minus 4. And I'm going to hit graph. And you can see my graph looks a little crazy. You're like, I don't see the normal coordinate plane. If you remember on a previous video, I adjusted this graph. I went to window, so that second button on the top row, window. Right now it's just showing 0 to 60, with every tick mark being 10. So I'm going to set it back to kind of what I think of as our standard, negative 10 to 10, and every tick mark is just 1. That's in the x direction. And then in the y direction, let's do the same. Negative 10 to 10, 1. And now if I hit graph, here we go. We've got our normal coordinate plane. You can think of it, the one we're used to seeing back. All right, it faces upwards. That makes sense. It was positive x squared. It does hit the x-axis twice, it looks like. And so what do I need? Well, I need to know exactly where it hits the x-axis. I can hit trace and try to figure it out, and 2, and nope, 2 wasn't it, and 3, getting closer. But there's a better way to do it than just trying to guess. And you might have guessed it has to do with that calculate menu again. So I'm going to go second trace to get to the calc menu. Remember, we've been here before to figure out where 2 lines intersect, that number 5 option. Well, here, we're not trying to calculate a value necessarily, or a min or a max, but we might later. What we're looking for today is the 0. You remember I said roots go by many names: roots, solutions, x-intercepts, or zeros. So I'm going to select calculate the 0 for me. And then, sort of like when we were figuring out where 2 lines intersect, we need to give the calculator a little bit of information. It says left bound. What that's asking us to do is set a left boundary. So you can see my cursor. I'm going to put it just to the left of the 0. I'm going to say this is my left boundary. And then it says right bound. I'm going to use my right arrow and move my cursor just to the right of the 0. And so now it's to the right of the 0. And then it says, can you take a guess? Get it close. That's kind of my guess. I'm going to hit enter. And it says 0 at x equals 4. Now you might be looking at that y equals 1e negative 12. Don't want you to worry about that too much. That actually has to do with how calculators store numbers and how they're not always exact. 1e negative 12 means exponent is what the e stands for. 1 times 10 to the negative 12th power, meaning it's 0.0000000000001. I think I got the right number of zeros there. It's basically 0. So when it's calculating the 0, when we use that calculate function, sometimes it might give you something there. Don't worry about it. If it says like 1e negative 12, that's basically 0. So we know that one of our zeros is at 4. And it looks that way from the graph. The other one doesn't hit exactly on an integer, it looks like. So I'm going to use second calc, ask it to find the other 0. It'll ask me for my left bound, so I'm going to move my cursor left. It might take just a second, but not too long. So there, that's my left boundary. I'm to the left of that 0, hit enter. What about the right bound? I'm going to move it just to the right of that 0. You can see the blinking cursor on the screen. I'm going to hit enter. It says, can you help me by getting a guess? I move it kind of close to where the 0 is. I hit enter. And it says, this 0 is at x equals negative 0.5. So I know that my zeros are at x equals negative 0.5. And you can write it negative 0.5. I would usually write that negative 1/2 just because I love fractions. But I'll follow the calculator in this case, and 4. So you might be saying, wow, calculator, nice. I didn't have to do any work there basically, except push a few buttons. I didn't have to make a table. I didn't have to graph it by hand, find the axis of symmetry and vertex. Calculators are super nice in this regard. One thing I would just advise you is to be sure you're reading questions carefully. If I ask you to graph something, and I'll try to be super clear about this, but if I ask you to graph it, I'm going to be looking for the graph. I do want you to know how to graph things by hand. There are lots and lots of standardized tests, for example, SAT, PSAT, ACT, where there's a no calculator section, and you need to be able to sketch out a quick graph by hand. So we might even have like no calculator problems where I say, don't use the calculator, graph this by hand. But as far as checking answers, always use your calculator. Just to check the answer, check your graph. It looks good. We know we did it correctly. And if you're just solving a random problem, say on an ACT, and you do have a calculator, this can be a really efficient way to find those zeros. So guys, that is all I have for you with section 2. It really is a nice extension of section 1, which has to do with just graphing quadratics. So graphing quadratics, finding the solutions now wherever they hit the x-axis when our equation is equal to 0. Hopefully this piggybacked really nicely on that last lesson. If you had questions, write them down so that you can bring them up next time we talk. But otherwise, I will see you guys next time.